Okay, this is going to go over questions 6 through 10 in your midterm review. For this problem right here, you have an absolute value inequality. Let me go ahead and show you how to do that on here. For an absolute value inequality, if you're going to do this by hand, you're going to first isolate the absolute value. Now, I don't have anything being added or subtracted, so I just want to divide by 5, negative 5. Now, the problem is when you're dividing by negative 5, this only works with dividing by negative. You actually have to reverse this. So it's going to go into greater than or equal to. And that goes back from inequality rules. So the absolute value of 4 plus x is greater than or equal to negative 15 divided by negative 5, which is 3. And then you have two inequalities to write. You have negative 3 greater than or equal to 4 plus x. And then 4 plus x is greater than or equal to positive 3. We want to, in this case here, subtract the 4 from both sides. And x is going to be, so you got negative 7 is greater than or equal to x. And then you got or, because they're going in, it's going this way. So you want to say or x is greater than or equal to negative 1. Now I don't like the way that works, so I'm just going to reverse that. X is less than or equal to negative 7, or x is greater than or equal to negative 1. On a number line, they are going to look like this. They're going to be closed circles. Negative 7 is your smaller number, negative 1 is your larger. And they're going to be shaded apart from each other. Here's how you do it on Desmos. On Desmos, you're going to type the entire inequality right and left side in. And then you're going to look at the shading. You're going to see where it crosses the x-axis. Zoom in and you see negative 7 and everything going to the left of negative 7. So that's this part here. And everything going to the right of negative 1. And we want to include both negative 7 and negative 1 because they're solid lines because of that equal sign. So when it's all said and done, your answer this will match kind of what your graph says. And like what we had over here, x is less than or equal to negative 7, or x is greater than or equal to negative 1. All right, number 7, the radius of the gears produced at a factory must be 6 inches in length with a tolerance of 0.1 inches. The gears with radius beyond the tolerated lengths will be thrown away. Write an absolute value inequality that can be used to assess which gears are eligible. X is the length of the radius. So all of them are going to look like this. Absolute value of x minus your ideal is less than or equal to your how much it can be off by. Just think about like the middle number. That's going to be your ideal. And in this case here, the radius of the gears must be 6 inches in length. That's where we're aiming for. So what we're going to do is we're going to plug in 6 inches into there. And then how much it can be off by, that's like tolerance or margin of error or something like that. Another word you might see is error. And that's going to go over there. So it's just going to be absolute value of x minus 6 less than or equal to 0.1. And they're always going to be like that. So if you can memorize that formula, you'll be good to go. All right, question number 8. An absolute value graph is shown below. If this graph is shifted 4 units and right 4 units, so let me take it right 4 units. 1, 2, 3, 4. And down 2 units. Down 2 units. Then what's going to be the resulting function? So we moved it here. That vertex right there is 1, 2. So what we're going to do is we're going to write y equals, this is going to be absolute value. So the way those work is you put the absolute value bars, and inside is going to be x. And then since this went to the right one, because we're looking from the origin, it goes right 1, so it's going to be minus 1. And then it goes up 2 to get to that point, so plus 2. This one's going to be opposite, and then this one's going to be the same. I threw that into the graph here just so you can visualize that. And you can see that opposite of that sign for the 1 there, and the same as the y value going up. So if you need to graph it just to verify, that's probably a smart idea on a test. All right, with this problem here, we're just going to we got to graph it and kind of see where the overlapped regions are. So let me go ahead and type this in. Make sure that when you are graphing these, you always never put f of x or g of x, just call it y, okay? Otherwise, it's not going to let you graph it. All right, give me a second to put all these in the graphs, and then we can compare. All right, here's answer choice A. That is not going to give you this overlapped region here, so that one's no good. After making some modifications, answer choice B, this shaded region here seems to be very similar to this, but got to note the dashed line versus the solid line. This one has the solid line up here, whereas the dashed line is down below, and this one's flipped. So we're not quite there. We need to fix that to be able to get it. So it's not going to be B. Answer choice C has the overlap region outside of these areas, so that's no good. So we know it's going to be D, and I can modify the inequality symbol so you can see this is going to be less than or equal to, so it's just less than or equal to. And then you can see how the solid line's there and the dashed line's there. And that represents the correct shaded overlapped region. So answer choice D is going to be the right fit for this problem. So we're going to circle D and just graph that. Remember, we're looking for overlapped regions here. Overlap. All right, last one. Number 10, which piecewise functions represent the graph below? So let me show you how to graph a piecewise function. All right, in order to graph a piecewise function as you see below, you're going to type the function in as you see it. And then where you see the inequality, you're going to do a curly bracket. Now you can get the curly bracket by typing Shift, the button next to P. And you can type the inequality as you see it here. And you can see here they're not really much different between your answer choices. One of them has a negative out front. So you can probably rule out that one. I'm guessing it's not going to be that one. And they all look pretty much the same. So really what it boils down to is the open and closed circles, right? Now, if you click over that, you want that one to be open. If you do, so you see an open circle there. You want that one to be closed. So we're good on that one. That's simply coming from, actually, simply coming from the inequality symbols over here. If you scroll over here, you got it closed, and right away you can see that that's not going to work. So we want this to be open here on the graph. So for this blue one here, which ends up being my quadratic, we need that to be just less than, not less than or equal to. If I click on it again, I get the open. And I want that to be 1 with the open circle there. So that one's good. Now this one here on the right side, I want these both to be closed, not open. You know, if you look at my graph here, they're closed. So those need to be equal to get those closed symbols. And actually this problem right here at -2, that should be equal to because that point for the green graph should be a closed circle there. So that should match up with the equal sign. And my graph didn't specify because it was an intercept, but if you click on it, you can see that point's on the graph now. So that is what we're looking for to get lined up to match that, which should give you one of these answers. So we're looking for, we can cross out C. it's going to be, looks like it's going to be the last one here. So answer choice D is the right call for this problem. And again, it's all about the open and closed circles. This is going to be closed. These ones are going to be open. And those correspond to these right here. Closed. Those correspond to those. And then this one's a hybrid of open and closed. So that's going to be open. And this one's going to be closed. So open, closed. All right, thanks for watching.